all for this discussion on case study approach for designing the negative feedback amplifiers for reducing the distortion in amplifiers. So in this discussion, our main aim is to analyze the negative feedback. Why we need negative feedback means in general common emitter amplifiers or other FET amplifiers, we have a distortion at the output when we vary the input signal. So we need to reduce the distortion and noise. So feedback is an essential concept for achieving this output. So we need to improve the stability bandwidth while reducing the noise and distortion. So this is our concept. So discuss the challenges and solutions of this case study one by one.
So negative feedback is a key concept in the amplifier designs. When we send the output signal back to the input, it may causes non-linearity. And when we apply negative feedback to the amplifiers, it reduces the non-linearity and helps to reduce the gain also. So in the open loop amplifier, where there is no feedback is applied, it may but have high gain, often reduces the non-linearity. So it helps to reduce the stability. It helps to improve stability and helps to correct the gain in the amplifiers.
Amplifier circuit distortion occurs due to non-linear behavior of amplifiers, active components such as transistors and operational amplifiers. When the input signal increases, the output waveform deviates from a perfect sinusoidal. So this introduces an harmonic. The harmonic signal degrade, such as especially in communication, audio, and instrumentational systems. The negative feedback means the process of negative feedback is introducing or applying a part of output, negative feedback, a portion of output waveform from output is negative feedback. Part of output is feeder into input, and the process is called negative feedback, and this results in the disorder or contract in the distortion. And this case study explains the clear analysis of negative feedback in distortion. So the principle of negative feedback is that feeding a part of output into the input, and this result in the distortion or contract in the distortion. So by subtracting the input with the output, the distortion or negative feedback can be defined.
Theoretical interpretation. When the amplifier produces the output, it usually contains distorted signals due to the non-linearities in the circuit components. In system with negative feedback, the distorted lines signals are cancelled and returned back to the input in the opposite phase. The feedback opposes the non-linear parts, and it cancelled the distorted lines. So this negative feedback cancels the distorted signals and improve the sound quality, stabilities, and make the performance smooth.
In theoretical analysis of distortion reduction, let DOL represents open loop distortion. When negative feedback is applied, the closed loop distortion TCL equals to DOL divided by 1 plus A beta. Thus, the reduction in distortion is directly proportional to the open loop gain 1 plus A beta.
Well, negative feedback reduces the distortion and also introduces the certain design traits of parameters of negative feedback. Distortion, it increases significantly. Gain reduces by 1 plus A by beta factor. bandwidth increases, enhancing of frequency response. Gain, stability improves if the product is designed properly. Noise may be increased due to the frequency network response.
Thank you for discussing your ideas on the negative feedback amplifier. So these negative feedback amplifiers are particularly useful in audio amplifiers, RF amplifiers, in communication system. So this will improve the stability and frequency response while reducing the distortion and noise. So thank you.
Thank you.